Hey, so what we are doing today is we are choosing when it is best to use the 3 different methods of solving that we learned this unit. So go ahead and put your name on here. And your hour. And we learned 3 different methods. Graphing is what we did in 3.1 and 3.2. Substitution was 3.4 and 5. And elimination was 3.6 and 3.7. So, it is best to use graphing when both of your equations are in slope-intercept. Because we are really good at graphing slope-intercept. So slope-intercept form is that y equals mx plus b. So if you've got both of your equations in slope-intercept form, y equals mx plus b, that is when it is best to use graphing. Because then we can just graph the 2 lines. Okay. Substitution is easiest for us to use, which is the substitution we did in 3.4, when one equation is solved for either x or y. So one of your 2 equations in your system is going to be x equals a number, x equals a bunch of stuff, or it might be y equals all your stuff. So you only need one or the other, and it doesn't matter whether it's an x equals or a y equals. But if one equation is solved for x equals or y equals, it's easier to do substitution. Okay. And then the last method of solving that we learned before break was elimination. It is easiest to use elimination when both of your equations are in standard form. So standard form, if we remember back to Unit 2, when we were graphing standard form. Standard form is when x and y are both on the left. So ax plus by equals c. So x and y are both on the left. On your test on Friday, there are going to be 2 problems that we tell you to graph, 2 problems we tell you to substitute, and 2 problems we tell you to eliminate. And then there is a page where we give you problems, and you can choose whichever method is easier for you. So some people prefer to do one or the other, but you can also use these rules of thought to pick which one to use. Okay, moving down, one more thing before we open this up and get to solving. We have 3 different types of solutions that we are going to see. Sometimes our system will have no solution. When we are graphing and we have no solution, what do those 2 lines look like? 2 lines that have no solution, what are they going to look like? How often are they going to cross? Never. So 2 lines that have no solution are never going to cross. 2 lines that have 1 solution are going to cross in 1 spot. And then two lines that have infinite solutions are going to be right on top of each other. Okay. When we are solving them out, one solution is what happens the most often. That is what happens when we are able to solve for x and y. And we get a solution, we write it as an ordered pair, x comma y. For both no solutions and infinite solutions, those happen when our variables disappear. So I'm going to write variables disappear on both of these. So no solution and infinite solution both happen when variables disappear. The difference, however, is what gets left behind. So for no solution, your variables all disappear and you are left with a false statement. For infinite solutions, your variables all disappear and you are left with a true statement. So, example of a false statement, something like 0 equals 5 or 2 equals 11. Those are false. True statements is either going to be the same number equals itself, so 5 equals 5, or a lot of times it'll be 0 equals 0. If you want to give yourself some examples there. Okay. So that is just review of things that have happened. Any questions before we open this up and start picking which examples to go where? And we're going to do half of them together. Okay, so we're going to start with graphing. For graphing, you are looking for equations where both equations are in slope-intercept form. So open this up. There are two spots to do graphing problems. The directions up here say, cut out the 6 systems, we did that. Sort them by which method is easiest to use, and then glue them under the correct method and solve using that method. So right now what I want everyone to do is look through their 6 little colored pieces of paper, find 2 systems where they are y equals mx plus b. They're in slope-intercept form. So you're looking for 2 systems that are y equals and y equals. Once you think you have those, set them aside, grab them. Okay, I picked these 2 systems because they are y equals, y equals, y equals, y equals. So I'm looking for all of the y equals for graphing. Go ahead and glue down the y equals 1/4 x first. Put that one on top. So the one that's y equals 1/4 x plus 3, put that one on top. And then the bottom one, let's put the y equals -4/3 x plus 5. Okay. For all of these, we're going to do one together, and then I'm going to give you guys a couple minutes to do the other on your own. And then we'll do it again. So we're going to do that top one together. That's why I wanted you to put that one on top, because it's the one we're doing together. So we're going to do that one. It's y equals 1/4 x plus 3 and y equals 1/4 x minus 2. So we're going to start at our y-intercept, which is 3. And then how do we graph a slope of 1/4? Up 1 and what? What's our slope? 4. You're good. Up 1, right 4. I can only do that one time, so I'm going to do the other direction as well. I'm going to go down 1, left 4. Okay, so I start at positive 3 on my y-axis. I go up 1, right 4. Twice. Okay. Then I can graph the other line. I'm going to start at negative 2 on my y-axis. I'm going to go up 1, right 4. So up 1, right 4. I can also go down 1 and left 4. Okay. When do these two lines cross? They don't. How many solutions do I have? No solutions, infinite solutions. How many times do they cross?
0.
0. So is that no or is that a lot? No. So that's no solution. So think how many times do they cross? They cross none. So I have no solution on this one. Okay. Any questions about that? Okay, I'm going to pause the video just so it's not running. Take like 3 minutes to solve out the next one. So to graph the next one. Okay, so flipping back to here, when is it best to use substitution? When one equation is solved for x or y. So find the two systems left that have an x equals or a y equals. So go ahead and do that. Let's look through your 4 systems you have left. You're picking 2 that have either an x equals or a y equals in them. Okay. I have this one where the first system is, or the first equation is x equals negative 2y plus 5. And I have this one where the first equation is y equals 2x plus 8. So let's glue those two down in that order. So put the x equals 1 first and the y equals 1 second, because that's the order we're going to do them in. Okay, so we are going to do one of these together, and then you guys will have one to work on your own. And we'll do the same thing with elimination. We started a little bit late today, so we will have, if we don't finish, I'll give you guys a little bit of time tomorrow. That's completely my fault and Arthur's fault and the weather's fault. So we've got x equals negative 2y plus 5. With substitution, we are able to take that negative 2y plus 5. Since it is x equals, we are able to plug that in for x in our other equation. So we are going to plug in x right here. Okay, so we are going to rewrite our bottom equation. It's going to be 3 times. We are plugging in that negative 2y plus 5 for x. And I still have minus 2y equals negative 41. Okay, we are going to start by distributing. Oh, any questions about the substituting in? Okay, so we'll start by distributing. 3 times negative 2y is negative 6y. 3 times 5 is 15. And then I still have minus 2y equals negative 41. So I distributed my 3.
Wait, let me answer. You might be right.
Okay. From there, we can combine like terms. So I can combine that negative 6y and that negative 2y together to be negative 8y plus 15 equals negative 41. And then I can solve for y. So I'm going to subtract 15 from both sides. I get negative 8y equals negative 56. And then we divide both sides by negative 8. And we get y equals 56 is 7 times 8. I have to say that to remember it. So negative 56 divided by negative 8 is positive 7. So we get y equals positive 7. Okay. Any questions about solving for y? Okay. I am recording this, so if you need to go back and catch up with something, you are more than able to do that at your leisure. It will be on the agenda. Okay, so since we've solved for y, we still need to go solve for x. So I'm going to take my other equation, that is the x equals negative 2y plus 5. I now know that y equals 7, so I can plug in 7 for y. So it'll be x equals negative 2 times 7 plus 5. Negative 2 times 7 is negative 14 plus 5. And then negative 14 plus 5 is negative 9. So I get x equals negative 9. And I can write my answer as an ordered pair. So x is negative 9. Y is 7. Okay. I am once again going to pause this video. 2 systems left. So by process of elimination, these should be our systems that we do by elimination. So we've got 2x minus 3y equals negative 20, 7x plus 6y equals 29. So those, see how the x's and y's are on the left? The x's and y's are on the left. Go ahead and glue them down in this order. So put the 2x and 7x one at the top. Because I want these all glued down before you leave this room, because if they're not glued down, they'll disappear into the ether. Okay. We are going to do one of them together. And then we will be out of time after we do one together. You guys can either choose whether you want to work on getting the other one done before Wednesday, or whether you want to use class time Wednesday to work on it. We will have our review Wednesday, so just keep that in mind. If you know you're going to need time to work on your review, and you want to work on this between now and then, you can. Okay, so with that first one, 2x minus 3y equals negative 20, 7x plus 6y equals 29. We need to either make our x's eliminate or our y's eliminate. Is it going to be either easier to make 2 and 7 be the same number, or 3 and 6? 3 and 6. Because 2 and 7 we could do, but we would have to change them both into 14. 3 and 6 we only have to change one of them. We can change that negative 3y into a positive 3y. Sorry. I don't even know why I said that. That was completely wrong. We can change that negative 3y into a negative 6y by multiplying our top equation by 2. And that'll make it so that our y's will cancel out. So I'm going to multiply our entire top equation by 2. I'm going to write it over here. 2 times 2x is 4x. 2 times negative 3y is negative 6y. And then that is equal to negative 20 times 2, which is negative 40. And then just because I'm over here, I'm going to rewrite my bottom equation. 7x plus 6y equals 29. So I just rewrote my bottom one. I didn't change anything about it. I was just rewriting it. Okay. We are going to add straight down, and our y's are going to eliminate. So 4x and 7x is 11x. Our y's completely eliminate. And negative 40 plus 29 is negative 11. Okay, from there, we are able to solve. So we can just divide both sides by 11. We get x equals negative 1. Now that we know what x equals, we need to solve for y. So we can take that negative 1 and we can plug it in for the y in either original equation. I always do the first one. So I'm going to take that top original equation, 2x minus 3y equals negative 20. And I am going to plug in negative 1. So it'll be 2x minus 3 times, I'm plugging in negative 1, equals negative 20. And then I just finished solving that out. So that negative 3 times that negative 1 is positive 3. So I've got 2x plus 3 equals negative 20. Something's wrong. What's wrong? What did I do wrong? I plugged x equals negative 1 in for y. That's an x equals, not a y equals. So it should have gotten plugged in for x. I am so sorry. Okay, so it should be, I was like, this isn't going to work out. 2x, so 2 times negative 1 minus 3y. Okay. Now we've got 2 times negative 1, which is negative 2, minus 3y equals negative 20. We can add 2 to both sides. We've got negative 3y equals negative 18. I'm running out of time. We divide both sides by negative 3. We get y equals positive 6. So go ahead and write your answer as an ordered pair. 6, negative 1. The bell's literally going to ring right now. I messed up again. What did I do? Oh, it's negative 1, 6. I needed another day of break. Okay. We will finish this on Wednesday unless you want to finish it on your own before then and have more review time Wednesday. So if you finish this on your own, we'll check it Wednesday. Otherwise, keep it until Wednesday and we'll work on it then. Sorry we ran out of time. Bye. I'm going to stop this video.